In this video, we're going to look at another example and to determine when or if improper integral converges or diverges. So the example we're going to look at is we want to determine if the integral from negative infinity to 0 of x e to the x converges or diverges. So first, we want to look at what this integral represents. So if we let f of x be the function x times e to the x over the interval greater than in negative infinity and less than or equal to 0, using Desmos or some other means from calculus 1, we can sketch the graph of this function over this interval. Here's what it looks like. The function is entirely below the x-axis, so it starts approaching the x-axis from below like that, and the integral represents this area enclosed by the x-axis and the function. And so because the area is entirely below the x-axis, we expect this integral to be negative if it exists, or if it doesn't exist, we expect the answer to be minus infinity. So this is something you want to do before actually evaluating the improper integral. Just anticipate what kind of answer you're going to get based on the graph of the function and the interval. So we're going to first express this improper integral in limit form. So the integral from minus infinity to 0, x e to the negative x dx. Here is the interval. It's from negative infinity to 0, so we're going to let t represent any negative number and let t slide to the left, so t is going to approach negative infinity. Therefore, this improper integral in limit form can be expressed as the limit t approaches negative infinity of integral from t to 0 x e to the x dx. So our first task here is to find an antiderivative of x e to the x, and we're going to have to do it using integration by parts with u equal to x and dv equal to e to the x dx. So then du would be 1 dx, and v is e to the x, and the integral is u times v, which is x e to the x, minus the integral of v du, which is just the integral of e to the x, and this is x e to the x minus e to the x. We can factor e to the x out, and this is that leaves x minus 1 times e to the x as antiderivative, with constant being 0. We really don't need c. So now we return to the evaluation of the improper integral from negative infinity to 0 x e to the x dx. In limit form, it is the limit as t approaches negative infinity of the integral from t to 0 x e to the x dx. And we just found this antiderivative, so this is the limit t approaches negative infinity of x minus 1 times e to the x evaluated from t to 0. So let's plug in 0 first. That gives us 0 minus 1, which is minus 1 times e to the 0. So minus 1 times 1, which is negative 1. And then minus, plug t in there, so it'll be t minus 1 times e to the t. And the limit as t approaches negative infinity does not affect minus 1. Therefore, we can just pull it. And so this is minus 1 minus the limit t approaches negative infinity of t minus 1 times e to the t. And we want to evaluate this limit. So in order for us to do it, we need to take e to the t and write it as, put it in the denominator as e to the negative t. Now let t approach negative infinity. The numerator approaches negative infinity, while denominator approaches positive infinity, and therefore we can use the L'Hopital's rule in order to evaluate this limit. So the limit is t approaches negative infinity. The derivative of the numerator is 1. The derivative of the denominator is minus e to the negative t. And this approaches 0 because the denominator approaches negative infinity while the numerator is 1. So therefore, we can now conclude that the improper integral from negative infinity to 0 of x e to the x dx equals to minus 1. So the area in that picture below the x-axis is equal to 1, and because it's below the x-axis, we write as negative 1. Therefore, the improper integral converges to minus 1.